Hi everyone, I'm David Gory, co-founder and CEO of Airbuild, and Airbuild at its core is preserving the most valuable resource on the planet, which is our water. Kind of similar to birth bioscience, but not as biology. Globally, 2.3 billion people lack access to clean water, and unfortunately, my co-founder Richard and I were two of those people. And it's estimated that the demand for clean water will surpass the supply by 40% in just 5 years. And this is more than just a third world problem. Here in the US, over 50% of our rivers are so polluted we can't drink, fish, or swim in them. And we all live close to some of those rivers. Did somebody say Willamette? And we've also seen, Dominic was talking about, the climate crisis being aggressively ignored right now. We've also seen the harmful effects of that crisis, from the temperatures rising up leading to droughts. Somebody talked about earthquakes. I just moved to Portland. I didn't know that was a thing you guys faced. There's a reason why I'm not in California. Maybe I should go back to Ohio. But best. So all these effects are real, and they're things that are around us, and they're affecting our water more and more. And we've seen the aggressive price tags that go with fixing these problems, from 1.3 billion in New Jersey to 4.5 in Boston. Airbuild is solving that problem by utilizing the organism, birch bioscience, that's responsible for over 50% of the carbon capture on the planet as we know it today, as well as is aggressively present in every polluted bed of water trying to do its job. And that organism is microalgae. Microalgae in the water takes out microplastics, PFAS, absorbs them into its cells, remove excess nutrients, heavy metals from those pollutants. So our systems are also powered by photovoltaics. So when we deploy, in one deployment, we're capturing carbon, generating energy with improved efficiency, primarily because we're mimicking the concept of photovoltaics, which is similar to Patasa. 85% of the energy from traditional solar is lost due to heat. But if you can find a way to reduce the operating temperature of those solar panels, you're boosting the efficiency. And that's really what we're doing with our systems, while also treating water. So we spun that core technology off into our flagship product that we call the Airbuild Pod. It's an enclosed algae raceway. We deployed this system, proprietary, if I might add, with our internal circulation system, closed with polycarbonate sheets, our proprietary phosphate coating, as well as the solar panels, as you can see. We deployed next to those polluted beds of water, so rivers, lakes, municipal sewer lagoons, because there are over 7,500 cities in this country, and we're talking hundreds of thousands globally, that pump their wastewater into holes in the ground and just leave them there. And when that happens, the water evaporates with methane, right? It releases methane, which leads to acidic rain, which pollutes our rivers. So we deploy next to those polluted beds. We pump the water in. The microalgae does its job capturing carbon while treating that water in that steady state. We send that solution into our harvester, where it's split between the microalgae itself and the treated water. We send the treated water down for further treatment through a 0.5 micron filter, as well as a UVC reactor, ensuring that the water that we send back into our rivers exceeds EPA discharge standards and can stop working to dilute the pollution in that system and restore that ecosystem. The microalgae, on the other end, is extracted and combined with local organic waste. So the waste that you typically would either incinerate or landfill, because those are also terrible. When you incinerate your waste, you're releasing methane, which again leads to acidic rain. And when you just leave it in a landfill, just like those holes in the ground where the polluted water is, it releases leachate, which goes down to contaminate the groundwater, which, as you all know, contaminates our rivers. So we combine the microalgae with that organic waste. We pyrolyze that biomass cocktail to create biochar, which is biological charcoal. It's great for permanent carbon storage, over 1,000-year permanence, as well as biofertilizer for local farmers. And there are a bunch of interesting companies that have been seen that are utilizing this material in their manufacturing processes of concrete, cement, asphalt, supercapacitors, batteries. There is a company that is using it for ink. There's a company that's using it for building insulation, which I found incredible. And the biochar that Airbuild makes, I call it really giving your biochar an espresso shot of nutrients, because the microalgae itself is housing all those nutrients from that wastewater. There are only two other companies globally that make biochar the way Airbuild does. One of them is HypeGeo out of UAE. They're at a stage similar to ours, and their goal is incredible. Their goal is to regreen the desert. So they spray the biochar in the Middle East with the goal of solving the Middle East food crisis. That should just be a testament to the strength of this. We ran our prototype at University of Massachusetts on a 52-gallon scale. We're taking water from the swamp that flows by the university. And upon successfully running that, we were able to determine the capture rate, get our preliminary biochar results, and then we were able to secure 37 acres of land in Green River, Utah for the incredible price of $1. That's primarily because the city was not only excited about the environmental benefits of our solution, talking about the water treatment, because as you can see here, this is 120 acres of sewer lagoons. We are currently estimated to replace these in just 3 acres on their land. So we are aggressively less land intensive than existing solutions, and also cost effective as well. This is the team bringing you the solution. We are a big team of about 16 right now. I think we just brought on like 3 more people, so like 19. Sometimes I can't even keep track. We're a team that has lived this crisis. I was born and raised in Nigeria, where I spent the first 16 years of my life. Growing up, we had to drink water from wells because our natural water sources were polluted. My co-founder, Richard from Kenya, lost his mother and sister to waterborne diseases. So we're a team that has lived this crisis, and we put our heads together, put our degrees, experience and all that, to build a solution that can hopefully solve this crisis for people in those situations globally. No one has talked about business model and all that, but we generate revenue through 3 streams. We're a utility, so we sell the water treatment part of our solution to cities, and then we step in to operate and maintain our facilities, kind of like the DevOps op. That's what it's called. And when we step in, we can then tap into the recurring revenue from the carbon offsets as well as the biochar. And our projects are profitable from year 3 off the recurring revenue alone. And we're also happy to say that all 3 of our revenue sources are proven to date. For competitor analysis, we're cheaper, faster, better, but that's really what everybody would say. I think a perfect story to that is in Redmond, Oregon. Whoever was at BVC has already heard this story before, so close your ears. In Redmond, Oregon, they spent $88 million and 82 acres of land building their water treatment facility, which, by the way, is not yet operational. And they built this facility to treat 4.6 million gallons of water per day. In Q3 of last year, we quoted Weber County in Utah $50 million and budgeted 42 acres of land to treat 4.6 million gallons of water per day. So as you can tell, we are roughly 50% cheaper than the existing solutions, but also aggressively less land intensive. And what's the only solution on the market that treats 4 tons of water per ton of carbon that we capture? Oh, this needs to be updated. We currently have in our pipeline $44.7 million. I'm actually going to be in Utah tomorrow to sign a $5 million contract with the city of Green River, because they're so impressed by what we're building that we are now working to scale that from that half-acre deployment to a 3-acre deployment, and the contract signing is set for the city council tomorrow. We also have other cities that are so excited to work with us that have signed documents to the tune of, like I said, $44.7 billion, and happy to have more conversations. So the goal of this enterprise, as you guys know, is we believe that water is a fundamental human right. As people who have lived without it, we know how important it is, and we're running out of it. And this doesn't even take into account the fact that data centers are being built like every other day. So we're raising our seed round right now and are going to be hiring, shortly after. We're slowly bringing on more people onto the team. So we'd love to connect if, you're interested in what we're building. Thank you.
Thank you. So is the role of the solar here to just provide power to the system?
That is it.
Okay.
The role of the solar is to power the systems, so we're completely upgrade.
Heat pumps and everything.
Heat pumps, everything, yes. And also, I forgot to mention, we have an operational facility on that land. Again, wrong slides, my bad. Yes.
Hi. I was curious because in the beginning you're saying algae will take out contaminants from water like PFAS, etc. And then you turn that into biochar. Does the pyrolysis process somehow break down those contaminants, or does that have to be treated in other ways not to create concentration?
So for the microplastics and PFAS, yes, it does, because the pyrolysis machine that we are looking at runs at 2,000 degrees Fahrenheit, which again breaks that down. It's also currently used in municipal breaking down of activated sludge, which our algae pretty much qualifies as activated sludge if you can think about it in that sense. So the 2,000 degree Fahrenheit will break that down, and that biochar can be land applied. But if we're tackling, say mining remediation or like the Michigan, Flint, Michigan issue, then that biochar would not be land applied. We can still pyrolyze it, but that biochar would then be sent for concrete and cement, asphalt, and those are the industries that do not send the biochar back down to the ground.
In a dark and stormy place like Portland, do you see decreased efficiency for algae treatment versus place like Utah that is a little bit more sunny year-round?
Definitely decreased efficiency, I would say, because again, algae is photosynthetic, but that's where the additional lights come in, so we can have LEDs in our system. Our system is its own individual greenhouse. I mean, we have trees here and they survive, so microalgae can as well. The things that we really need to worry about with the algae is the temperature and the light exposure. Light exposure, simple. We have LEDs there that are pretty much working to keep that circadian rhythm going. That solves that crisis. And for the temperature, we're thermoregulating it with heat pumps, as well as recycling the waste heat from the pyrolysis into the pods as well. So we're built to scale globally. I mean, people are cultivating microalgae in Canada.
Anybody else?
I was in Japan going to the World Expo, and in the Japanese area, they have this microalgae sea where food production and many other uses are being explored. So my question for you is that how do you really, on one hand, protect your IP, but on the other hand, also develop it further?
So we're lucky enough to be working with Ideaship Fund out of Portland that's handling our IP management. We currently have full patents on our pod process. We have provisionals on the entire process itself. We're not developing a proprietary algae strain. We're just using the local algae strains that exist on the market because, again, you can't bullshit nature. We can put whatever algae we want in there. Nature is going to do its cause, which is pretty why we have algae blooms in every river that we look at. So we are protecting our IP with the help of Ideaship. We have patents on our processes right now. And again, this goes beyond just the deployment. There's the operate and maintain part of it, which is something that our competitors cannot also.
How do you have it?
So we were working on our research. We have so many PhDs on our team who are researching and we're filing patents. I believe there's a new one that's coming out about our harvester that's being worked on. So really anything across carbon, water, algae, waste, biochar, we're hoping to be one of the research leaders in that. If not, we'll just acquire, right?
Speaking of the kind of maintenance and operation piece, are these staying near cities or are these going on for remote areas?
I mix it both. Just wondering how that.
A mix of both. Right now in Green River, we're in the city because we're not only treating the city's wastewater, we're also taking water from the Green River itself, which I found out was a joke like last week. Somebody told me the water is green because they called it the Green River because the water is green because of the algae. I realized it was named the Green River long before that. So, running joke, my bad. But yeah, we're deploying in the cities. where it's needed. We can also deploy remote. One of our committed customers, Richfield, their water treatment system is very remote. They're talking about 60 miles away from the city, and we can deploy there too. We're fully off grid, so we don't need to be close to the cities.
And last question.
You said you just with local algae, and you don't have a monoculture of some IP algae.
No, we do not.
Okay, I see. So how do you maintain consistency? Like whether you're in Portland versus whether you're in Boston, the local algae that you source is going to be different. So your product's going to give different efficiency. So how do you?
Yes, so we start off with Chlorella vulgaris, which is really what every algae water treatment company will tell you they start off with. But we're not cultivating pure cultures because, again, we're burning it. We're literally cultivating the algae to burn it. So we don't care about the culture or the strain in the algae. It can be a combination of microalgae and bacteria that's in there. That's irrelevant. What we care about is the quality of the water being treated. So the efficiency of the carbon captured will definitely fluctuate based on, or the amount of the carbon, I will say, not the efficiency, will fluctuate based on the strain. But as far as we can keep hitting that water treatment rate, because regardless of a strain of algae, it's going to capture carbon. We know that's a fact. It's going to take out nitrogen and phosphates. It's going to take out heavy metals. Now, depending on the PFAS or microplastics content, that's where you need to start mechanically engineering your strain. So in that scenario, we could then tap in and have secondary clarifiers that have the proprietary strain that's needed for that system, like Navicula.
Okay, thank you, David.
Awesome.